Hello. This videotape is going to cover the operation and construction of the plasma tube beam ray device and its effects on some selected microorganisms. At the moment, what you are looking at here is a phanetron diode in operation. And it's going to shift frequencies here, just like that. And as it does, you notice the plasma became a little more intense and a little brighter. And we moved from about 700 cycles to about 7,000 cycles. I'm going to try and let you listen to a little bit of that for just a moment. Is partially formed from an electrostatic field around the tube and also comes out of the CB unit. This is an overview of the device itself. At the bottom right we see the linear amplifier, on the left is a CB radio and the power supply. Coming up is a function generator. This is a Kinnaman unit and it allows one to sequentially output 19 frequencies simply by pushing a button. This is our antenna tuner by MFJ, and currently it's tuned at about 1.6 or 7 to 1 SWR. Behind is the plasma tube. This happens to be an argon-filled quartz tube. This is the oscilloscope tracing of the device in operation. And what I did was place a probe about 6 feet away from the device while it's running. And I've switched audio frequencies, and I've moved from like 700 to 800 to 900 to 1,000 cycles. And as I switch frequencies, you'll see that the pulse narrows and becomes more frequent. This is my dark field microscope, which is a combination of parts from other microscopes, but primarily it's an Alcgena. This is a 100x objective, and in a 100x objective you need an internal iris diaphragm, and the little ring I'm turning there is for the diaphragm. This is what's known as a cardioid or catioid type of dark field condenser with a little mirror on the bottom. This one happens to be made in Russia, and it's by Lomo microscopes. Here's our little mirror. Now what the device does is it produces a wave that is easily accepted by cellular organisms. And at the right frequency, the organism will accept the wave and begin to vibrate. Just like that. This particular pond water organism, it's a little protozoan, has a frequency that it is currently responding to of 8,296 cycles. And you can see it's pretty well shaking him up. If you ran another frequency, this would not happen. Now, if you let this organism be exposed to this frequency for long enough, it will eventually die. It does not explode, it just dies. Just basically shakes it to death. If one were to take and turn the device off after about a minute of exposure, the organism continues to shake like this for about another 2 to 3 minutes. And providing that it has not been killed at that time, it will basically go back to swimming in its prior to being agitated state. This structure was found in the blood of an individual that has an elevated PSA level, which relates to the prostate. It was undergoing exposures to the device, and this was found in the blood after one of the exposures. In my volume 1, there's quite a bit of debris in the blood of one particular individual that's shown on the tape of cancer cells that broke down from the effects of the device. Whether this structure is from a cancer or not is unknown. This is a Folosirea protozoan organism. Normally, they are highly motile and swim around the slide quite freely. At the moment, this particular organism is under the influence of the wave and is undergoing a disintegration process. Its interior is basically disintegrating. A Folosirea generally is a complex organism. In this case, most of the interior structure is being destroyed by the device. In a moment, the actual cell wall will rupture. As the organism disintegrates, most of its internal structures just break down into these small little particles. And when the